Good day, everyone. Welcome to the STEM Digital School. This is grade 6 Natural Sciences and Technology. My name is Unkarabetse Setswe. Guys, today we will be continuing with term 2 revision. All right, just a few ground rules, guys. Please, no switching on of the webcams. Okay, so please do not switch on your videos throughout the lesson. And if you do have any questions, you can raise your hand, then I will unmute your mic, or you can just type it in the group chat. And again, guys, let's keep chats to a minimal, okay? So let's keep chats to what we are dealing with in class, all right? Also, another thing, if I am going too fast, just use that go slower button, right? Just press it, then I will just give you guys some time to write out whatever you might be writing. Okay, so I see you guys already testing it out. Okay, all right, cool. Let's get on with it then. Okay, so as mentioned, next week, Thursday, we're writing the Natural Sciences and Technology test. And I said that it is on life and living, as well as meta and materials. Okay, life and living, as well as meta and materials. So all the topics under life and living, as well as all the topics under meta and materials. And that is why, guys, this week we have been doing revision. So this was also a means of actually studying. Okay, so today we are looking at the next topic, which is mixtures. So this is under meta and materials. Okay, so mixtures is just under meta and materials. Okay. First question, what is a mixture? So you guys were required to make summaries as well as notes. So yeah, what is a mixture? According to the summaries that you have, I believe, in front of you, or notes. Okay, beautiful. Mahlori?
Hello, ma'am.
How are you?
I'm fine, and you, ma'am?
I'm well, thanks.
So, a mixture is a combination of two or more substances.
All right, beautiful. Thank you very much for that wonderful answer, Mahlori.
Thank you, ma'am.
Awesome. So Mahlori says a mixture is when two or more substances are combined together. All right, so let us see if Mahlori is correct, and that is true. A mixture is two or more different materials or substances that have been mixed together. All right. And then, can you guys think of examples on mixtures? Can you guys give me examples of mixtures? You can write them in the group chat, or you can raise your hand to give me an example of a mixture. An example of a mixture. Okay, I see Kamohelo in the group says raisins and peanuts. Kia says salt and water, which gives us salt water. Right, so that is, those rather are examples of mixtures. All right, perfect, guys. Beautiful. Let us see what we have on the slides. Okay, so it says you can mix two solids with each other, such as salt and sand, or different coins. So that will also be regarded as a mixture. If I have sand, right, as well as coins, then I have a mixture of sand and coins. Okay, I see Kia also says pap and meat. That is correct. It's a beautiful mixture and a beautiful meal. Okay, next point that we have, it says you can also mix a solid with a liquid. All right, so an example would be ice mixed with cool drink. Okay, or another example is sand and water. Then we can also mix two liquids together, such as oil and water. Okay, so here we have just some examples that were mentioned. I believe Kamahelo said peanuts and raisins. Here we have, I'm not sure if those are ducks, but yeah, ducks and water. Okay. I was required to go back to this slide. So I'll just wait a minute before I move on. All right, okay, Kia?
Yes, ma'am. I just wanted to ask a question.
Okay, go for it.
Are ducks and water really a mixture?
Yes, they are a mixture.
Oh, okay.
Because we see them together. You see, we see the water, we see the ducks, and they're in one place or in one pond. So the
Oh,
pond
okay,
would be a
ma'am.
mixture of the ducks as well as the water. Not that they they intertwinkling with each other. Ne?
Okay, ma'am. Thank
Sure.
you, ma'am.
Awesome. Okay. All right, cool. As we move on. So these are the pictures that I had shown you guys. Ne? Kia's asking if ducks and water are really a mixture. Okay, so here we have a mixture of different colored jelly beans. Okay, and just there on the top right hand corner, we have a mixture of various fruits. That is what we would call a fruit salad. Okay, and then bottom right, we have a mixture of juice concentrate as well as water, and we refer to this as juice. Okay. Okay, so mixtures where different substances are clearly visible. Yeah? So you guys, if I can just go back, we can see here in these various pictures, or 4 of these pictures, here we can see the different colors of jelly beans. Here we can see the different substances, which is our raisins as well as peanuts. Here we can see the water as well as the ducks. And here on this picture in the top right corner, we can see the different fruits in this mixture of fruit salad. Okay, so that is what we mean when we say mixtures where different substances are still clearly visible. All right. So the different materials are still clearly visible after mixing. An example is our fruit salad or different colored jelly beans. And then these mixtures can be separated by physical methods. So I need examples of physical methods that we can use to separate these mixtures. Okay, Gia?
Thank you, ma'am. An example of separating mixtures is hand sorting.
Hand sorting. Okay, can you give me an example of what mixture we can hand sort?
Jelly beans.
Jelly beans. So you can put the different colors, right? You can put the red on one side, the yellow on the other side, and the purple on the other side.
Oh, okay, ma'am.
All right, beautiful. So thank you very much, Gia, for that example. So Gia says we can use hand sorting when we sort our jelly beans. Okay, so can I have another example of physical methods that we can use to separate mixtures? Another example which we can use to separate mixtures. You guys can raise your hand or you can type it in the group chat. All right, yeah, I see you on a roll.
Oh, thanks, ma'am. Another way is extracting, but I really don't know what to extract.
What does extracting mean?
Extracting is separating.
It means separating. So it's another word for
Yes,
separating.
yes.
Okay, but extracting, now remember, when you say we are extracting something, it means that we are taking it out.
Oh,
Yeah,
okay.
so
So
it
what
would,
can you extract?
we can extract, if I have a mixture of lemon, right, and water, I can extract the lemon from the water using my hand. So that would automatically mean that it's hand sorting. It will fall
Oh,
under
you
hand
slice
sorting.
this. Oh, so you slice the lemon and put it in the water.
And then
And
I'm
then when you want
extracting the
to
lemon.
extract it, you take out the lemon.
Yes. So it would be hand sorting.
Okay.
Yeah, because I'm using my
Okay.
hands. Yeah. All
Thank
right.
you, ma'am.
Awesome. Okay, guys, other examples, other examples. I give you guys you did notes and summaries. So please share. Please share the different methods. Okay, I see Mashori. All right. Go for it, Mashori.
Ma'am, we can sieve the mixtures.
Sieve the mixture.
Ma'am?
Did you say we can sieve the mixture?
Yes, ma'am.
All right, awesome. So what type of mixture can you sieve?
Ma'am, let's say for example, you have a mixture of of sugar
Mm-hmm.
and you have rice mixed in with it. You can simply put it in a sieve and the sieve will allow the sugar to pass, but the rice will stay inside the sieve.
All right, beautiful. Thank you very much for that, Mashori.
Thank you, ma'am.
Awesome. Guys, make sure that your videos are off, all right? Please keep your videos off. Thank you very much. So we had an example of hand sorting. We also had an example of sieving. Anyone, last one? Anyone who wants to give us a last example of physical methods that can be used to separate mixtures where the different substances are clearly visible? Kia says, I got nothing. All right. But you did give me an answer, which was beautiful. All right. Anyone else? Okay, so I see Dr. Law in the group says orange and water, rice and mushroom. Okay, so Dr. Law, how would you separate the rice and the mushroom? How would you separate the rice and mushroom? Okay, so you guys are really quiet. Is it the cold? All right, cool, no problem. Let us move on and look at the different physical methods of separation. Right, so Mahlori mentioned sieving, right? Using a sieve, and the example that Mahlori gave us was sugar and rice, saying that the rice would go down the sieve, or rather the sugar would go down the sieve and the rice will remain. Okay, so that is how we would separate a mixture of sugar and rice. Okay, so here we also have an example where a builder uses a spade to throw a mixture of sand and rocks. Okay, so the sand will go through the sieve and the rocks will remain on top. So another example where sieves are used is in the kitchen. I'm sure if you guys have been in the kitchen while someone was baking, they would use a sieve to sieve the flour, right? So that lumps would remain on top and then the fine flour would go through into the bowl. All right. Okay. So let's see, the next method that we have is hand sorting, and Kia gave us an example of hand sorting. And Kia said that we can hand sort the jelly beans into their various colors. Okay, so even another example is the peanuts and raisins. We can separate the peanuts with our hands, right? Put the raisins on one side and put the peanuts on the other side. Okay, then we have what we call filtering. Okay, filtering, here we can use filter paper, right, to separate solid material from a liquid. that solid material might be coffee grains, right, and water. So if we put filter paper, then the water will go through the filter paper and the coffee grains will remain on the filter paper. Okay, so it will basically separate the water and the coffee grains. Okay, next physical method is settling and decanting. Okay, settling and decanting. Here we have an example of settling and decanting. So careful decanting of water to leave settled sediment behind. So when you talk about sediment, the sediment would be this brown color here, all right? So that is what settles at the bottom. That is what we refer to as sediment, okay? And then we just need to be careful if we don't want the sediment to enter the water. So that is why we say careful decanting needs to take place, all right? So guys, these are the four methods of physical separation that we can use. Okay, so since I saw that only 2 people answered and you guys only gave me the first 2, so here are the second, or rather the third and the fourth one that you guys can just add on to your notes. Okay, so the third one is filtering and the fourth one is settling and decanting. Right, can I move? Can I move on to the next slide? Can you say yes or the no icon by participants? Guys, can I move on to the next slide? I'm going to need you guys to respond, please. All right, cool, awesome, awesome. Right, so guys, in other mixtures, the materials are mixed so thoroughly that it seems as though one material has disappeared into the other. Okay, so that type of material we would, or rather that type of mixture, we would say that it is a solution. Okay, so an example was the juice, right, where we have juice concentrate with water. Okay, so I believe you guys also saw it in the slide that appeared with the examples of mixtures. Okay, so key concepts for mixtures. A mixture consists of 2 or more different mixtures mixed together. Sometimes mixtures can be separated into individual materials again. Some of the ways in which mixtures can be separated are sieving, filtering, hand sorting, and settling, followed by decanting. Then when a material changes from a solid to a liquid, the process is called melting. When a material forms a solution in another material, then the process is called dissolving. Melting and dissolving are 2 different processes, and we are going to look at this in greater detail in the next slides. Okay, so yesterday we did look at melting, I believe. We looked at solids, we looked at liquids as well as gases. Yeah? So today we are just moving right along. Okay, so next topic is solutions as special mixture. I think my mixture just disappeared there. It's solutions as special mixtures, right? Okay. When do we say a mixture is a solution? When do we refer to a mixture as a solution? When do we refer to a mixture as a solution? Guys, question. I see the best friend. Hi, best friend. Welcome. But when is a mixture a solution? I need hands and I also need answers in the group chat. When is a mixture a solution? Okay. Kamohelo, you've been quite active in the group chat, ne? So I'm going to require an answer from you for this question. When is a mixture a solution?
Ma'am, a
Yes.
mixture is a solution when you mix the. Ma'am, I'm not sure.
You're not sure. Do you have your textbook in front of you?
Yes, ma'am.
Okay, check for me in the textbook. What does your textbook say? Now you hadn't opened in on the page that we're on now.
Yes, ma'am. But I have a different kind of textbook.
Guys,
Alright.
remember, ne, whatever textbook that you are using, just open on the topic that we're dealing with now. Ne? Follow in your textbook as well as on screen. So remember I said that this topic is under matter and materials. Again, right now we're looking at solutions as special mixtures. Have you found it, Kamohelo?
Ma'am, give me 2 minutes.
2 minutes. Okay. Okay, so do we have anyone else who can answer when is a mixture a solution? Guys can raise your hand or you can type it in the group chat. When is a mixture a solution? Okay, Piwa, thank you.
Ma'am, a
Right, Piwa?
mixture is a solution after mixing it.
After mixing it. And how can we differentiate between a solution, right? As well
Ma'am?
as, okay, so remember in the previous slides, we looked at the peanuts and the raisins, correct?
Yes, ma'am.
And we
Yes,
said
ma'am.
that is a mixture. And then we
Yes,
also had another example of juice.
Yes, ma'am.
Okay, so what's the difference between those two mixtures? Which one is a solution and which one is just a mixture?
Ma'am, the peanuts and raisins is a mixture. It's just a mixture, and the juice
Okay.
is a solution.
Okay, so why is the
Because
juice a solution?
the juice is a solution because if you mix juice and water together, they are both liquids. So it's gonna be very hard to separate them again. And the peanuts and raisins, you can hand sort them, and that's easier to do than to try to separate the juice into both juice and water.
All right, beautiful. Thank you very much, Piwa.
Thank you, ma'am.
Awesome. Okay, so Piwa says in the example that, or rather in the example of peanuts and raisins and juice concentrate and water, the juice concentrate and water would be what we refer to as a solution. Okay, and Piwa also mentioned that in the juice and the water, it will be very difficult to use the physical methods of a separation. Okay. I see in the group, Gia says that when two mixtures are mixed together, it is a solution, and after the mixture is done stirring, it's a solution. Okay, Tokelo says when you get two mixtures to mix or more, the right answer is okay. All right. So guys, next. Solutions are mixtures in which the separate particles cannot be seen, even under a microscope. So remember the example that I asked Piwa to choose, ne, which, like the example I used of peanuts and raisins, as well as the juice. Ne? in the peanuts and raisins, it's a mixture, but we can see what's involved in the mixture. We know that it's peanuts as well as raisins, and we can see the different substances which have been mixed. But in terms of the juice, we had the juice concentrate as well as water mixed together, meaning that you cannot tell by just looking that there is water, there's also juice concentrate in that cup. Okay, so it looks like one thing. So there is dissolving that took place. Okay, so I hope everyone follows and understands what a solution is. Remember, solutions are special mixtures. Okay, so you guys can just write that down in your notebooks, that solutions are special mixtures. And that is because we cannot see the separate particles. We cannot see the separate particles. Okay, so if you do not understand and you want me to explain again, you can just type it in the group chat, or you can raise your hand if you do have a question. Okay. So guys, just more information. The substance that looks as if it has disappeared, it is called the solute. And then the substance that we can still see is called the solvent. All right. So a solution always has what? A solute as well as a solvent. Okay, then the solvent and solute together are called the solution. Okay. Solvent and solute together, they are called the solution. Okay, guys, can I move on to the next slide? Or do you guys still need some time? You can just use the yes and no button there by participants. I believe it will be much faster. All right, so let us look at soluble substances. Soluble substances. Guys, please also follow in your textbooks. Follow in your textbooks. The reason why I said you should make summaries and notes was so that because we're using different textbooks, it will be much easier to actually go through this if you have your summaries and notes. Okay. So a solution forms when a solid dissolves completely in a liquid. All right. So remember we spoke about something that dissolves, and rather in the previous example that I gave you about the juice concentrate as well as the water. Okay. So it says that a solution forms when a solid dissolves completely in a liquid, or a liquid dissolves completely in another liquid. Okay. Then a soluble substance is one that forms a solution when mixed with water. So a soluble substance, that's the key word here, soluble. It is the one that forms a solution when it is mixed with water. So this soluble substance, we would even refer to it as the solute. Okay. Then every solution has a solvent and solute, just as mentioned. And here we have an example of sugar and water, a sugar and water solution. And the sugar is the solute and the water is the solvent. Very important to note that water is a very good solvent. Okay, water is a very good solvent, and water is the example of a solvent that we'll be using in many of the examples that we will be doing. All right. Then separating the solutes from solvents, we cannot separate solutions using physical means. Okay. It is, however, possible to separate or recover the solute by evaporation. Okay. And this process is called crystallization. So this is when the solid remains behind in the container and it looks like small crystals. So example, if I have a beaker of water as well as salt, if I want to separate the water from the salt, then I would need to heat the water and wait for all the water to evaporate, and then my salt will remain behind in the beaker, leaving the crystal salts behind. Okay. Then saturated solutions. A saturated solution is when no more solute can dissolve in a given volume of solvent. Then if you put too much sugar in your tea, some of the sugar will be left over in the bottom of the cup, even if you stirred the tea several times. Then saying that a solution is saturated means that the specific amount of solution you are working with has become saturated. Okay, so that is also a key term that you need to know, guys, the word saturated, okay? And then an unsaturated solution is one where it is possible to dissolve more solute in the solvent. And then lastly, some substances will not dissolve to form a solution in water, and these substances are called insoluble substances. Okay. So I see a go slower there. Do you need me to go back to the previous slide? Do you need me to go back to the previous slide, or should I remain on this one? Okay, I see a no. All right, cool. So I believe you guys just want this slide. Okay, I'll give you a minute or two, and I will ask a question so long. Give me an example of an insoluble substance. Give me an example of an insoluble substance. Remember, we said the insoluble substance is a substance that will not dissolve in water. So I need an example of something that we add in water and it shall not dissolve. Okay, so I see Kia and Sibu say sand. All right, beautiful. Another example. Another example besides sand. Okay, Kia and Mashori, just indicate for me when you're done. Indicate for me when you're done so we can move. Okay, Kia says mud. Okay, but mud is already a mixture, right? So mud would be a mixture of the sand and water. Okay, glue. All right, okay, yeah. So glue would not mix in water. All right. Thank you for that one, Tukelo. No, Kia, that one it would mix in water. Okay, so P would mix in water. It is soluble. Sugar is soluble. Remember, I said insoluble substance, something that will not mix in water. So Kamohelo, if we mix sugar in water, it will dissolve, all right? It will dissolve. Okay, oil, yes. Oil is an insoluble substance. So oil does not mix or dissolve in water, all right? So oil does not dissolve in water. It usually settles on top of the water. So Mahlori, remember, just indicate for us when you're done. Okay, Kamahela says wood. All right, that is correct. Wood would not dissolve in water. Okay, cotton wool is also an example of an insoluble substance, as well as metal and bread. Yes, that is correct, guys. So all those are examples of insoluble substances. Perfect. Okay, so key concepts for this topic that we have just covered. A solution is a special kind of mixture Like all mixtures, it consists of two or more substances mixed together. Then a solution is made up of a solvent, such as water, in which one or more solutes have been dissolved. In a solution, the solute looks as if it disappears into the solvent. This is because the particles of the solute and the solvent become closely mixed. There are many kinds of solutions, but the most well-known ones are mixtures of solid and a liquid, such as sugar and water. Then the next point reads, not all substances dissolve in water. Those that dissolve are called soluble substances, and those that do not dissolve are called insoluble substances. So those are the examples that you guys just gave me now. Yeah? Then solutions cannot be separated by sieving, filtering, hand sorting, or cycling and decanting. This is because solid particles are dispersed between the solvent particles. Then solutions can be separated by heating so that the solvent evaporates. The dry solute will be left behind, and remember, we call this process crystallization. Okay. The last point reads, when we have dissolved so much solute in the solvent that no more solute can possibly dissolve, we say that the solution is saturated. Okay. Right, so I hope we are good to go with that topic, and we are moving on to the next topic, dissolving. And I did this topic with you guys when I first started off. Okay, so we're just gonna move through it. Rates of dissolving. So dissolving involves incorporating a solid into a liquid to form a solution, all right? Then when a substance is dissolved into a liquid, it takes time for the particles to disappear completely. Then the speed at which dissolving happens is called the rate of dissolving. Very important to note that the speed at which dissolving happens is called the rate of dissolving. And then we can measure how fast a substance dissolves in a solvent to form a solution. Okay, factors that affect the rate of dissolving. Can you guys give me those 3 factors that we looked at when we were looking at this topic? The factors that affect the rate of dissolving. You can raise your hand, or you can just type it in the group chat. Okay, beautiful. Yeah.
Thank you, ma'am. The factors that affect the rate of dissolving is temperature, rate of stirring, and size of particles.
All right, beautiful, awesome. Thank you very much for that. Okay. So Gia said that it is temperature. So it would be the temperature of the mixture. Gia also said it is stirring, and it is stirring or shaking the mixture, as well as the grain size or the size of the particles. So it is the grain size of the solute, yeah? Grain size of the solute. Well done, Gia, on those beautiful answers that you gave us. So guys, if you do not know the factors that affect the rate of dissolving, these are the 3 factors, okay? So you guys would remember that we looked through investigations or experiments with regards to temperature of the mixture. That's when we changed the temperature of water, right? And we were looking at how fast the sugar would dissolve in warmer water and less warmer water, right? And then the stirring and shaking a mixture, we also did an example of that in class, right? Where in one beaker we were stirring, right? And then in the other beaker, we did not stir anything. So we wanted to see which one would dissolve faster. And then we also had an experiment where we looked at how grain size of a solute affects the rate of dissolving. If you guys can remember, there was one where we used coarse salt, right? And the other one where we used fine salt, right? And we were comparing the two, and from that we concluded that the experiment where we used the fine salt dissolved faster, okay? So can I move on to the next slide? Are we good? Right, awesome. Okay, conclusion. So a fair test is a test in which you only change one factor and you keep all other factors the same. So fair test, remember guys, we looked at it when we were doing the experiments, né? Where we only changed one factor in the experiment and all the other factors we kept constant or the same, right? Then an increase in temperature caused the rate of dissolving to increase. We saw that, and as we increase the temperature of a liquid solvent, you give more energy to particles of the solvent, making them to move faster. Then a higher temperature increases the rate of dissolving. Smaller grain size also increases the rate of dissolving, and a faster stirring intensity increases the rate of dissolving. Okay, key concepts. The time it takes for a substance to dissolve is called dissolving rate or the rate of dissolution. Then the rate at which a substance dissolves can be affected by three factors, and that's the temperature, stirring or shaking, as well as grain size of the solid. Next point, a solid will generally dissolve faster if the solvent in which it dissolves in is warm. A solid will dissolve faster when the solution is stirred or shaken, and a solid will dissolve faster if the grain size is small. Okay, so guys, this brings us to the end of our lesson. So if you do have any questions, just type them out in the group chat, or you can raise your hand so that we can address them. Okay. Tomorrow, guys, please make summaries and notes, okay, on the following topics: mixtures and water resources, as well as processes to purify water. Okay, read through the topic of mixtures and water resources, as well as processes to purify water. All right. And if you do have any other questions with regards to these topics, then you can ask in class tomorrow, and that will bring us to the end of our revision. Okay. So please, guys, make those summaries and notes. And honestly, tomorrow you guys are gonna share with me. Everyone is going to share their summaries and notes with me, because it seems like you guys are not doing your summaries. Okay. And these are the textbooks I used for the lesson: the Via Africa Natural Sciences and Technology textbook, which you can get on Snaplify, all right? And we also use the Siyavula textbook, which you can get on the Thunderbolts Kids website. And guys, if you do have any questions or you want me to share the slides with you, you can email me, or you can email the school at stemdigitalschool@africateamgeeks.co.za, and my email address is also right there. So guys, have a beautiful day further and enjoy the rest of your classes. Also, please keep warm, guys. Keep warm. Bye, guys.